Hey guys, Mr. Creed here. This will be the final video for March 30th notes. Stay tuned for the rest of the notes for this week. I'll post those to Canvas and to YouTube within the next few days. So we're going to talk about sample space. The last video was talking about compound events, and a good way to represent compound events is through a sample space or tree diagrams, okay? So let's talk about sample space. Sample space describes all the possible outcomes of an event, and a sample space can be created with lists, tables, or tree diagrams to determine the probability of simple or compound events. Simple events involve just one event occurring. Compound events that consist of two or more events. Okay, so let's talk about one. Let's talk about one event here. So, the New England Patriots and the Dallas Cowboys are playing. What are the possible outcomes of the game? Well, we can look at this two different ways. We can look at it as a list. As you see on the left side, Patriots win, Cowboys lose, or Cowboys win, Patriots lose. Okay, so or you can do a tree diagram. Patriots, Cowboys. Either the Patriots win or lose. Either the Cowboys win or lose. Okay, so both teams have a 1 in 2 chance of winning or losing. Okay, all right. Number two, a number cube is rolled. What are the possible outcomes? Well, I'm only rolling one cube or one dice, so I could have 6 possible outcomes. A cube has 6 sides, therefore there are 6 possible outcomes. 1, 2, 3, 4, 5, and 6. The probability of those rolling one of those numbers are the same if I roll it 6 times. All right. So let's talk about number three. Okay. Number three for breakfast. Jamie chooses from cereal, eggs, or muffin. She could also drink coffee, orange juice, or milk. What are the possible outcomes, and how many total outcomes are possible? Okay. So I'm going to draw for the next 4 problems, or next I think 5 problems. I'm going to draw a I think it's just I think it's just three or 4 problems, whatever, something like this, whatever. Okay, I'm going to do a tree diagram. It says here to do a list or a table, but I think tree diagrams are a lot more kind of easier. So I'm going to show you how to do that. Okay. All right. So I only want y'all to see one at a time, so I'm going to zoom my screen in a little bit. Okay. So we got this right here. Okay. So I've already listed a tree diagram. Okay. And for my first choice, I'm choosing between cereal, eggs, or muffins, something to eat with. Well, a lot of times when you eat something, you gotta have something to drink with, right? So for each choice of food, I am choosing a drink. I can choose with cereal, I can have coffee, orange juice, or milk. With eggs, I could have coffee, orange juice, or milk. Or if I chose a muffin, I could have coffee, orange juice, or milk. Okay. So if I were to list this, okay, I'm gonna list this out here. I could have cereal with coffee. Okay. I could have cereal with OJ or orange juice. I could also have cereal with milk. Okay. Or I could have eggs and coffee. I could have eggs and orange juice or OJ. Or I could have eggs with milk. Okay. I could also have muffins with coffee. I could have muffins with orange juice, or I could have muffins with milk. All right, so this would be like a list. Okay, if you want to do it as a table with one side being food, one side being drink, that would be fine as well. Okay, see how that takes quite a bit of while. Here, I just abbreviate everything. A tree diagram will work there as well. Okay, so I have 9 possible outcomes for the food choice and the drink choice. Okay, and remember, if you use the fundamental counting principle, We're just taking the first event, the first outcome of the outcome of first event, multiply it by the outcome of second event. You'll get 9 in this case. You have 3 food choices and 3 drink choices. 3 times 3 is also 9. Okay. Number 4. Okay. At registration, a student can select from Spanish, German, can select from Spanish or German class, as well as art, music, or theater. 2 events. Okay. So I have a language class of some sort, either Spanish or German, Spanish or German. Or I could have art, and the second event, I could have art, music, or theater. Okay, so for a tree diagram, it's what like this right here. Okay, I have Spanish with art, Spanish with music, or Spanish with theater, or German with art, German with music, or German with theater. So for a list, it would look like Spanish with art, or Spanish with music, or Spanish with theater. Okay, or it could be German, German with art, German with music, or German with theater. Okay, that would be your list as well. Well, there's 6 possible outcomes for that list. Okay, or that tree diagram. 6 possible outcomes. Okay. All right. Lastly, here's a tree diagram. This is a big one. Okay, I'm going to be tossing a fair coin 3 times. Okay, we'll toss a fair coin 3 times. Now, this coin could be a quarter, could be a dime, could be a nickel, could be a penny. As long as both sides are different, either heads or tails, then we're good to go. So this coin, I'm going to toss it. The first toss, I can either get heads or tails. Okay. So with that first toss, let's move on to the second toss. Well, I could also have either heads or tails, but if it landed on heads, I could also have a heads or tails again. But if it landed on tails, I could also again have heads or tails on the second toss. Okay. The third toss is represented by this list right here. It could be heads or tails. Okay. Be heads or tails, heads or tails, heads or tails. So toss 1 and 2. Toss 1, I have just only 2 outcomes, either heads or tails. Okay, toss 2, I could also have either heads or tails. So my outcomes for the first toss 1, I have 2 outcomes. 2 outcomes. Toss 2, I also have 2 outcomes, either heads or tails. And then toss 3, I could also have 2 outcomes, either heads or tails. Okay, so if I use the fundamental counting principle, I can just do 2 times 2 times 2 to figure out my possible outcomes. Which would also be 8. Here is a visual representation of this. Okay, so if the first toss was heads, second toss is heads, the third toss could also be heads. Okay, if the first toss was heads, second toss was heads, third toss could be tails. So here's I got heads, 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 tails. Okay, for third toss, I could have I can move on to from heads to tails and back to heads. So I can have heads, tail, heads. My fourth toss could be going from heads to tails to tails. So heads, tails, tails. So these is representing each 3 tosses. Okay. So I have 4 possible outcomes so far, all of which are different. Okay. All of which are different. And especially in the order that they have been flipped in. Okay. So let's say my first toss was tails, second toss was heads, and my third toss could be either heads or tails. Well, in this case, it's heads. So I got tails, heads, heads. Okay. Sixth toss could be tails, heads, tails. Tails, heads, tails. Okay. My seventh toss could be tails, tails, heads. Tails, tails, heads, as you see here. And tails, tails, tails. Could be my eighth toss. Tails, tails, tails. So I have 8 possible outcomes. This will be a tree diagram here. Okay. Again, I am branching off each possible. Sorry about that. I could have a different. Sorry, I lost my train of thought there. So each toss can either be heads or tails. Okay, but if I toss, my first toss can branch off here, and each toss after that is going to branch off even further. Okay, so if I have 4 tosses, it could be branching off these right here, all the way down again. Okay, So 8 possible outcomes. Here's your list of possible outcomes. Um, Again, like this video, comment if you have any questions. Join in tomorrow. Join in each week from 8 o'clock to 10 o'clock for a Zoom session. If you have questions on your homework or any kind of notes that I have, I have whenever today. Okay. All right. See you guys later. Thanks.